Hey guys, today we're going to be answering the two-sum LeetCode problem, number 1. So the problem statement is given an array of integers nums and an integer target, return the indices of indexes of two numbers such that they add up to a given target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So the important thing to realize here is that for this array, we can iterate over the array of elements, and a naive or brute force approach would just be to use or utilize a nested for loop, or basically a double for loop to check. So let's just say that we checked each item like this, so 2 plus 7 will equal 9. Let's say that didn't exist, that wasn't the first one. Let's just say that we checked this one next, 2 plus 11, that does not equal 9 equals 13. And that would actually yield a time space complexity of O(n) squared because of the double for loop, and O1 space. So one thing I want to advise you guys as like a general pattern, if you're noticing that you're using any type of time complexity, n squared, n cubed, or n to the 4th power, there might be a way to essentially memorize or remember portions of the processing you do, or there might be ways to store or pre-process it so you have a lower time complexity by utilizing more space. So that's a trade-off we're going to be thinking about when we use a data structure called a dictionary or a hash map. So instead of using a nested for loop, we can potentially store or remember results so we don't have to double iterate or reiterate over things. So what does a dictionary or hash map do? What exactly is a data structure? Think about it as a collection of key value pairs. So imagine that we have a key and a value, and it's surrounded, let's just say, by these curly braces. So in this case, we're going to be wanting to use two integers as the key and value. So let's say that you want to utilize the difference and store that index. So for example, let's say that you wanted to store the difference between the target and the current nums value, so 9 minus 2. So you would store the key of 7 to index number 0. And then let's say we iterate over that again. So let's say next we have the value 7. 9 minus 7 equals 2. So and then we would check if there were any values that equal that. So in that case, actually I believe we can just store that right here. So it wasn't 7, it was actually 2. So once we get the target and we see that it's actually in this dictionary, we can just return 0 and 1. So again, we're just remembering the process we take, and then if we find that key further on along in this process, we should remember it and we can access it in constant time. So that's one of the pros of right here, the pros of hash maps search. So anytime you search a key within a hash map is done in constant time, or O1 time. The same with adding keys or inserting keys to a hash map, and deleting keys as well. It's all constant. Now, one of the cons obviously is it's not ordered, but knowing this, we're going to be we can utilize a hash map in order to save the processing power and not have to do n squared time. So essentially what we could do is we could do it two ways. One way, we would have to go through the array twice. So imagine we just use a for loop and we just iterate through. So these little dots are the iterating. We iterate through the array and or the elements, and we actually add them to the hash map. So let's just imagine we add that to the hash map. That's the first array. And then the values here, so key value. And then when we go through here, we iterate through the array again. But this time, we check the difference. So let's just say difference is target minus current value. And then if the diff is not in the hash map, then we add it. Oh no, we pass it. If it is, so if it is, then we would just return that hash map's key that has the diff value, and then the actual index itself. So one way we can actually make this better, this would actually be done in O(n) time. We can actually avoid doing a double loop at the same level, so we wouldn't have to do this. We would actually just add an extra step. We would add that diff to the hash map down here. So we're actually moving from going through the array twice to once. So hash map dot add, and then it would just be the current value and the index. So yeah, that's just simply what we do here. In Java, it's called a hash map. In Python, it's called a list, and in JavaScript, it's also called an array. So they all have different ways to instantiate it, but at the end of the day, what we're essentially doing is moving or reducing the overall time complexity by increasing the space by creating and utilizing a hash map. And then for our logical step right here, all we're doing is we're moving from going through the array twice to, for this generic for loop right here, iterating through the array. We check to see if the array exists in the hash map. If so, we return the value in the hash map with the diff value and the current index right here. And then if not, then we just add the current diff. So again, that basically consolidates the two for loops into one. So let's go straight into answering it. All right, guys, we're going to do our Java solution. We're not going to be doing the brute force or n squared solution because it's just a double for loop where you iterate through those elements and then just return two different keys that equal the target. So we're going to be focusing more on the hash map related sections and solutions. So what we're going to do first in Java is create our hash map of integers. So we'll do that right now. And in our first part of the solution, we're going to essentially use two different for loops. They're not nested. So the first one's going to be adding values and their index. And the second one is going to be iterating and finding a difference between the target and the current value, seeing if it's in that hash map, and then if so, returning those two different indexes. And also as part of that second for loop's conditional and checking the key, it's also going to make sure that index for the difference found in the hash map does not equal the current index. So we want two different indexes, and you'll see that a little bit more clearly through the code. But yeah, let me just make a hash map called val idx pairs. I just think it's nice and simple because it obviously shows that we have a value and an index. So new hash map. Okay, so for the first for loop, we're going to just do your standard for loop. And then we're just going to be adding to that. So put nums I, so the current value and the current index. The second for loop, same thing. I'm going to be iterating through every single element. We're going to create a difference or a diff variable that is an integer. So we're going to want it to be the target minus the current value. So that's the ith element in nums. We're going to check if this diff is in val idx pairs that contains key. So that's the way for you to check in Java if a key exists in that hash map. So remember, we're searching in constant time, so that's why this hash map as a data structure is so useful. And also, we just want to make sure that the current diff does not, and that index that's its value does not equal the current index. So that's going to make sure that we do not get the incorrect one. And since our output variable is an array of ints, we're just going to set it to that index value for the diff that we just created, and then our current index. And if not, we're going to just return an array of integers that are -1. Okay, let's check this out. Oh, I forgot to add a semicolon. Okay, so you can see that we've basically solved this using a hash map, but you can kind of notice that we use 2 different for loops. We can actually simplify this code a lot by just adding to the hash map as we go. So we actually don't need that first for loop. We can just add this part of the code to the bottom of this for loop. So after this conditional check right here, we just add the current value in the index, and it'll still work. Instead of doing 2 for loops that are at the same level, we'll just do 1. So you'll notice that this also solves the answer, and it actually does it slightly faster. So this is the Java solution. All right. Okay, cool. All right, guys. For the Python solution, which is after our Java one, we're going to be setting up a Python dictionary and just be iterating for the same thing. So create the hash map and go through it one time, and one of the solutions is going to be with 2 different for loops at the same level. One's going to be adding to the dictionary, and then one is going to be checking for differences, and then returning different indexes that combine to the selected target. And then we're going to consolidate that to one for loop. So yeah, let's create this dictionary. Let's call it pairs. That'll just be easy. Python, you can initialize a dictionary through these curly braces. So we will iterate range len nums. Oops. And then we're just going to be adding to that. So for that value, we're just going to be giving it that index. And then for the second for loop, we're going to be creating a variable called diff. It's going to be our target minus the current variable. We're going to see if this diff in pairs and pairs diff does not equal the current index, then we're going to return a list of the pairs diff and the current index. And let me just correct the small misspelling. And then we're just, if that's not found, then we'll just return an array of -1. So this is only if you haven't found it. So let's run this, see if it works. It does. So if we were to run this, it would work too, but we can actually consolidate this for loop into just 1. So instead of 2 at the same level, and this is an O n time, this consolidation of 1 for loop is just going to remain the same time, but do it in only 1 for loop. So it's slightly better. So yeah, all we actually have to do is move this line here. So after we check the diff in this array, we can actually just add it right here. So I have that double for loop. We have it right here. Let's just remove that spacing. Boom. Now let me run it again. you'll see that we have answered as well. And yeah, that's how we solve two-sum in Python. Thanks. All right. Hey guys, for this JavaScript answer, we're just going to do the optimized solution instead of the brute force n squared solution. And the two solutions that we're going to be working on is they both use the hash map, but they do it in slightly different ways. So the first way, we use two for loops at the same level. So that's O(n) time and O(n) space for the hash map. But the optimized solution is just slightly better because we're able to do all the different processes in one for loop. So let's go through both really quickly. So I'm going to create a dictionary. So let's just call it pairs for JavaScript. And then we're going to iterate through this array. So from that pairs, we can actually index it from the current value. So why is it important for us to do the current value in the index? Because we're going to be looking for that in the second for loop to find the complement or the difference that's attached to the current index. So the second for loop, same thing. Oh, I forgot the less than symbol right here. So this less than symbol, nums.length. So same thing, we're going to create a diff integer or diff value. Is going to be the target minus the current value. So this current value is the ith element or the current element at index I in the nums array. So right here, now we're going to see if diff is in pairs and pairs diff does not equal, not equal to the current index. So if that's the case, then we're going to return an array of the index for the key diff in pairs and the current index. But we also want to make sure for this second logical or conditional statement that the indexes are not the same. So that's the little thing right there. And then if we can't find it, we'll just return an array of two indexes and -1 to note that we are not able to find a pair. Okay, let's see where it went wrong here. Oh, the Java slipped out a little bit. So we have to do the variables as this in JavaScript. Sorry about that, guys. Okay, so one kind of optimization here is instead of having to use this two for loops at the same level, you can actually just add that key value pair after you've checked for it in the hash map after it. So it's going to actually do all the processes within one for loop. So we made it slightly better. So instead of two O2n space is O(n) space. Obviously the constants get dropped, so they're both the same time complexity, and they both have O(n) space too, but this makes it just slightly faster and better. So it's obviously a little bit more concise, but the logic is relatively the same. So that's how you answer this in JavaScript. Thank you guys, and see you guys in the next video.